When we think about geometric series problems, the hardest part is just remembering all the formulas. Luckily, you get a formula sheet, but just make sure you keep everything straight. So when it says rewrite the following geometric series in sigma notation, we're just going to do sigma, and sigma doesn't change, which is nice. Sigma is still going to be n equals 1 to your last term n. And then here we put the formula an. We just need to make sure we use the formula for geometric. So n equals, in this problem, there are 1, 2, 3, 4, 5 of these. So we put a 5 here. And then to find the formula, this is the part that really makes geometric really shine, is that here's a 1. And then to find r is simply going to be a2 divided by a1 because we have adjacent terms. So that's just negative 18 divided by 6. So that's just negative 3. And with geometric, that's all I have to do because the formula is a1, right? And then we put in here, we put in r, and then we put the exponent n minus 1, and we're done. And so the nice part about this, unlike arithmetic, geometric, I'm already done with that problem for the first part. Now, to evaluate the series, that's going to be this formula, S of n is equal to a1 times 1 minus r to the n. And here I just have to be careful. Okay, I need to make sure that when I do this, of course, I'm evaluating 5 terms. A1 is, of course, 6. The careful part comes here. I need to make sure that I put r in a parentheses. And depending on the calculator you use, or if you're using a tablet when you're trying to use Desmos, you may even have to put a parentheses on the top and the bottom. And just don't forget to actually put n here as well. So some students will forget to actually put the 5 there or the whatever. And then we're going to just use Desmos. So when we type that in, right, we just have to be careful. We put a 6 here, open a parentheses. We do 1 minus negative 3, close the parentheses, and then raise it to the 5th. And it really is important to highlight this whole thing and then divide. Now, you could put a parentheses around the whole thing and divide. That's your choice. And if you're using a tablet, you're going to have to do it that way. And so you see, nice thing about Desmos is it's very visual. You can see you got it right. So adding up those 5 terms will add up to 366. And the reason that number is so small is because, well, some of the terms are positive and some of them are negative. So it's actually adding and subtracting as it's going from term to term. Remember, r is negative, so it makes sense that we see this alternating, adding and subtracting. So let's take a look at 2 problems that actually are in sigma notation. Notice that this one's a 0 term, which we'll talk about. It's just like arithmetic, though. We just use a different formula. So let's look at the basics. The basics are this sigma notation means this formula. But there's one thing you might notice is that how do you know you use this formula? There's no indication that it's geometric other than the fact that they put a geometric an formula here. So you have to be aware that they're not going to tell you it's a geometric. They're going to say do sigma, and you have to look at it and be like, oh, the formula is geometric as opposed to arithmetic. So to find n, it is just 12. To review that, to do inclusive subtraction, you actually take this, subtract this, and always add 1. It's not really a big deal if it's at 1, though. You can easily just determine that n is 12. All right, and that 12 is also going to go up here in this exponent. Okay, so a1, this is the part you have to be very careful of. A1 could be this term right here, but I would advise you to put 1 in and just make sure. If I put 1 right here, I get negative 2 to the 0. This crosses out, and in fact, this is a 1. And that will always be the case if the sigma starts at 1, but it doesn't start at 1 over here. So just kind of hold that thought for when we do problems later. All right, but in this problem, we're good. So we just do 1 minus r. The beautiful thing about r is always the thing in the parentheses up here. So r is negative 2 right there. I'm going to put that down here in a parentheses as well. And then I'm just going to type this thing into the calculator or into Desmos. So we really need to get familiar with how this works and how to type this in. I have had students in the past that sort of just watch me do it and they think they're good. And they're not, because it does take a little practice. Like, for instance, I got to click right there. I got to then raise it up. I then have to highlight the whole thing and divide. There's a lot of little steps in there that if you don't have practice with, when you take the actual test, you might make a mistake. And you saw that I was making typos as I did it, and I was able to see it and correct it. And that just takes experience. So if you do type it in correctly, this one comes out to negative 9,555. So the last one we're looking at here, it has a 0. And this is what happens when there's a 0. First of all, we are using this formula. And as I said before, you want to write down the formula for every problem. It is the secret to getting an A or a B plus on the test is to have the appropriate formula. Well, in this problem, the first thing I need to understand is that that A1 is actually A0, right? It's not a 1. If this was a 12, I would write an A12 here. Okay, the n is found by doing this, right? The n is to take these things. N is 5 minus 0. Inclusive subtraction, you have to add 1 back in, so it's actually 6. And if you count on your fingers, 0, 1, 2, 3, 4, 5, that is 6 things. You might want to pause the video and stop that and count on your fingers, 0, 1, 2, 3, 4, 5. You'll be holding up 6 fingers. All right, then over here we have 1 minus r. R is always r. It's no big deal. Just make sure that this 6 is also a 6 that goes right there. Okay, so r is a third. All right, so we're just going to put that 1/3 in there. And the only correction we have to do now to the formula is figure out what A0 is. A1 means first term that you are given, not necessarily the first term in the sequence. So the first term we're given is 0. So to find A0, we'll come over here and say A0 is 6 to the 1/3 to the 0 plus 2. You can use a calculator if you want to. This one's pretty reasonable because it's just 1/3 squared, which of course is 1/9. So A0 would be 6 times a 9th, which comes out to 6/9 or 2/3. So you have to figure out the first term if it doesn't start at 1. If this is not 1, or if this exponent is wrong, you have got to make sure you know what the first term is. So now that I know that this is 2/3, I could just run this formula like I ran the other one so far. Formulas are great, but they have to be done within the characteristics in which they are designed to be used, and that's what we had to do with that A0. So just keep in mind that sigma means this formula, but it has to have the right stuff. All right, so to type this one in, this one actually has quite a surprising answer. You get 2/3, and notice that I have a fraction. I got to click over here to the side, open a parentheses, 1 minus another parentheses. Okay, I'm then going to click between these two parentheses and raise it to the 6th power. And then I'm going to highlight this whole thing and then divide and then 1 minus 1/3 again. Okay, and notice that it comes out to this answer. Now, what's surprising about this answer is that it actually is a fraction, right? Always double check and toggle this little fraction, or if you have a TI, use the fraction thing where you hit Alpha F1 and hit enter. This actually comes out to 728 over 729, which is very, very close to just saying that the sum is actually 1. I just want you to think about that for a minute because it explains why when this is infinity later, the formula actually changes. And we'll talk about that in just a moment. But I just want you to kind of think about the idea, first of all, that we thought the answer was a crazy nonsense answer, but when we toggled it to a fraction, it actually came out to 728 over 729. And secondly, there's implications here because this is just basically 1. Okay, so just keep that in mind as we look at other problems in a few moments.